So, good afternoon, everyone. I am Ellen Marie Alcaida, and I will be your first discussant for today's discussion. So, before we will proceed to our discussion, let us have first the learning objectives. So, the first one is to define the different measures of variability for a group data, such as the range, the average deviation, the interquartile range, the variance, and the standard deviation. Next is to compute the range, average deviation, interquartile range, variance, and standard deviation using the ungrouped assessment data. Next is to interpret the level of variability in students' scores and explain what it indicates about the students' performance and consistency. And lastly is to value the role of measures of variability in making fair and evidence-based assessment decisions. To begin with, I have here the top 5 scores of two groups in a quiz, which is from English Tastic A and from English Tastic B. So I want you to observe their scores. So after observing, I have a question. So considering the scores from the two groups, who do you think the group performs better? So this could be answered by our lesson for today, which is the measures of variability for ungrouped data. So what is measures of variability? So measures of variability, also known as measures of spread or dispersion, so this describe how far apart the values in a data set are from each other. So in learning assessment, so this describes how much student scores differ from one another. So in educational assessment, these measures of variability helps teachers understand how consistently students perform, not just by what the average score is, but these measures show the spread of dispersion of scores, giving insights into learning patterns, students' difficulties, and overall effectiveness of the instruction. So why variability matters in learning assessment? First is for better interpretation of class performance. So variability shows whether most students performed close to the average or if the scores were scattered. So low variability suggests that students had similar levels of understanding, while high variability indicates differences in mastery, which may require differentiated instruction. So next is for identifying gaps, comparing different groups or sections. Next is for monitoring consistency and reliability. And lastly, for supporting instructional decision. So, knowing how spread out the student scores helps teachers plan interventions, adjust teaching strategies, and set realistic learning goals based on the actual performance pattern. Measures of variability help teachers understand how spread out student scores are, revealing the consistency, the diversity in performance, and the potential learning gaps. So there are different types of measures of variability. The first one is the range, denoted by the capital letter R. So it is the simplest way to describe variability. So it is the difference between the highest and the lowest scores or value in a set of students' results. So we have here the formula for the range. We have R is equals to HB minus LV, where R is the range, HB is the highest value or the score, LV is the lowest value or score, and then we have the interpretation for the range, which is the higher the range, the greater the spread of values or scores. So example, the data scores of the English Tastic A. So we have here 50, 36, 24, 20, and 10. So all we have to do is to find the highest score. So the highest score is 50, got by Karil, while the lowest score is 10, got by Ronyan. So all we have to do is to substitute. We have here 50 as the highest value minus 10 as the lowest value is equal to 40. So our range is 40. So the scores of English Tastic A are dispersed. So it implies that their scores are heterogeneous because the spread of their scores are higher. The next type of measures of variability is the interquartile range, denoted by IQR. So this measures the spread out of the middle 50% of the student scores. So it is the difference between the third or the upper quartile and the first or the lower quartile. So the formula for IQR is Q sub 3 minus Q sub 1, wherein the Q sub 3 is the third quartile. So the median of the data points to the right of the median in the ordered list, while the Q sub 1 is the first quartile, or the median of the data points to the left of the median in the ordered list. We have here the steps in finding the IQR. So the first one is to arrange the data values from the smallest to largest. Next is to determine the median. Next is to determine the first quartile. Next is to determine the third quartile. And the last is to solve for IQR by subtracting the first quartile from the third quartile. Example, so we have here the data scores of the English Statistic A. So we have 50, 36, 24, 20, and 10. So the first step is to arrange them from smallest to largest. So we have here 10, 20, 24, 36, and 50. And then the next step is to determine the median. So the median of the scores is 24, as you can see, because there are 5 scores in the example. So as we count 1, 2, 3, 4, 5, so in the middle is 24. So the median is 24. So next is to determine the first quartile. So to determine the first quartile, all we have to do is to sum up 10 plus 20 and then divide it into 2. So we have 10 plus 20 divided by 2 is equals to 15. So our Q sub 1 is 15. And then the next step is to determine the third quartile. So we have here the third quartile is 36 and 50. So we have 36 plus 50 divided by 2 is equals to 43. So our Q sub 3 is 43. Now let's solve for the IQR. So the formula is IQR is equals to Q sub 3 minus Q sub 1. So let's substitute. We have Q sub 3 as 43 and minus Q sub 1, 15. So the IQR is 28. So the next one is the average deviation, or the AD. So it measures the average value by which any value in a distribution deviates from the mean of a data set. So we have here the formula for the average deviation. So we have here for the sample, AD is equals to the summation of the absolute value of x minus x bar over n. While for the population, we have AD is equals to the summation of the absolute value of x minus mu over n. So in which AD is the average deviation, x or the mu is the mean, and the x is the individual value, and the n is the total number of values. So, for example, you have the scores of the English Statistic A. So, you have 50, 36, 24, 20, and 10. So, this will become our x, or the individual value. And then, to complete the formula, we need to find the x bar, or the mean. So, to find the x bar, or the mean, we need to sum up all the x, or the individual value, and then divide it into 5, since there are 5 scores. So, we have 50 plus 36 plus 24 plus 20 plus 10 divided by 5 is equals to 28. So, our x bar, or mean, is 28. So, next is to compute the absolute value of x minus x bar. So, all we have to do is to subtract the x bar from the x. So we have 50 minus 28 is equals to 22, and the absolute value of 22 is 22. Next is 36 minus 28 is equals to 8. So the absolute value of 8 is 8. Next is 24 minus 28 is equals to negative 4. So the absolute value of negative 4 is positive 4. Next is 20 minus 28 is equals to negative 8. But then the absolute value of negative 8 is 8. Next is 10 minus 28 is equals to negative 18. But then the absolute value of negative 18 is positive 18. So next, we will sum up these numbers. We have 22 plus 8 plus 4 plus 8 plus 18 is equals to 60. So we have here our summation of the absolute value of x minus x bar is equals to 60, and then we have our n is equals to 5. So we can now substitute for the formula. We have 60 divided by 5 is equals to 12. So our average deviation is 12. So the scores are 12 units from the mean.